Hello AP Calculus, this is lesson 76, integration of odd powers of sine and cosine of x. By way of review then, if I gave you an integral like this, the integral of sine of x dx, what would you say the integral is? You should say negative cosine of x plus c. Or if I were to say what's the integral of cosine of x dx, what would you say? You would say sine of x plus c. Also, by way of review, if I said what's the integral of sine squared x cosine of x dx, you would say, I know how to do that. That's a U substitution problem. I recognize that sine squared of x is a composite function and that the derivative of the inner function, which is u equals sine of x, is right there, cosine of x dx. So I take the derivative of u equals sine of x, I get du dx equals cosine of x. In other words, du equals cosine of x dx. I get the integral of u squared du, which then I could finish up by saying the integral of u squared is 1/3 u cubed plus c, which is the same as 1/3 sine of x cubed plus c. Now, new stuff. What if I gave you something like this? What's the integral of sine squared x dx? The answer is you have no idea how to approach a problem like this, and I'm not going to show you today. That will remain a mystery. And now, also by way of new material, what if I gave you sine cubed x dx? Well, this is a mystery to you as of now, but it will not be a mystery by the end of the period, because part 5 right here, question 5, is the type of problem we're handling today. Notice, the inner function is sine of x, and the outer function is an odd power function. That's what we're dealing with. Integration of odd powers of sine of x and cosine of x. All right, let me show you the technique then. The first thing I'm going to want to do is split up sine cubed x into definite integral of sine squared x times sine of x dx. You want to reduce the power by 1. That's the trick. Reduce the power by 1. Now, you're almost at the place where you can do U substitution. One more pre-calculus trick. You use a Pythagorean identity on the sine squared x portion, the even portion. 1 minus cosine squared of x. We've got sine of x dx. At this point, you've converted the problem into a U substitution problem. Here's my composite function, and the derivative of the inner function, cosine of x, is sine of x. U equals the inner function, which is cosine of x. Du dx equals negative sine of x, which implies that a negative du equals sine of x dx. Therefore, integral is now the integral of 1 minus u squared negative du, put the negative sign out here. And we integrate this as negative u minus 1/3 u squared plus c, or negative u plus 1/3 u squared plus c. And that in turn becomes negative cosine of x plus 1/3 cosine squared x plus c. Let's try another example. The definite integral of cosine cubed x dx. What's our strategy? First, split up cosine cubed of x into cosine squared x and then cosine of x dx. You want to reduce that power from an odd power to an even power by extracting one of the cosine of x's. Then you're going to want to use a Pythagorean identity. So this will equal the cosine squared x. The even portion becomes 1 minus sine squared of x. Left cosine of x dx. Now you got a classic u substitution problem. U is going to equal the inner function of the composite, which is sine of x. Therefore, du dx equals cosine of x. And du is equal to cosine of x dx. Therefore, our integral is 1 minus u squared du. Anti-differentiating, you get u minus 1/3 u cubed plus c, which equals sine of x minus 1/3 sine cubed of x plus c. Now we get variations on the theme. Definite integral of sine of x to the 4th power times cosine cubed x dx. Same strategy, apply it on the odd power, which would be the cosine cubed x. And so we get definite integral of sine of x to the 4th power times split up cosine cubed x into cosine squared x, cosine of x dx. Now, what are we going to do? Same thing as before. We're going to take the definite integral of sine of x to the 4th power, and that cosine squared x, we're going to apply a Pythagorean identity at 1 minus sine squared x times cosine of x dx. This in turn equals sine of x to the 4th power minus sine of x to the 6th power times cosine of x dx. You'll notice you're up to the u substitution phase at this point. So here's your composite function. Therefore, the inner function is sine of x, and du dx is equal to cosine of x, or du equals cosine of x dx. Right on. This will equal u to the 4th minus u to the 6th du, which equals 1/5 u to the 5th minus 1/7 u to the 7th plus c, which equals 1/5 sine of x to the 5th minus 1/7 sine of x to the 7th power plus c. Here's one last example. The definite integral of sine cubed x cosine of 7x dx. In this variation, we got two odd powers of sine and cosine. You just have to reduce the power of 1 to an even power. Choose sine cubed x because it's smaller, easier. So this is the definite integral of sine squared x times sine of x times cosine to the 7th x dx. Now, you use the Pythagorean identity. So this is 1 minus cosine squared x times sine of x times cosine of x to the 7th power dx. And you reach the u substitution phase. U is going to be the inner function of this composite portion. So the inner function is cosine of x, and therefore du dx is equal to negative sine of x, or negative du is equal to sine of x dx. All right, our integral then. What's it equivalent to? This is 1 minus u squared. Cosine, this part here, cosine 7th x becomes u to the 7th. And then I'm just left with this last little bit, which is sine of x dx, and that becomes what? Negative du. So put the du here and the negative sign on the outside. Now distribute. You get negative u to the 7th minus u to the 9th du, simple integration. 1/8 u to the 8th minus 1/10 u to the 10th plus c. This is going to equal negative 1/8. What will u become? U is cosine, so this is cosine 8 of x plus 1/10 cosine to the 10th power of x plus c. And that's all there is to the lesson, folks. It's pretty straightforward. It'll probably be on a test. It will probably not be on the AP exam.